Welcome friends to my YouTube channel. Now in today's lecture, uh, I shall going to discuss about a new topic, that is momental ellipsoid. Momental ellipsoid, or more commonly it is known as ellipsoid of inertia. Okay, so this is the three axis, say x axis, y axis, z axis. Okay, so we consider a particle here P, say mass m dash. We consider a particle at P of mass m dash of the rigid body. Okay, the rigid body is composed of large number of small particles. So this is the origin O. So we have to find out the moment of inertia about, say, this axis. Say this is R. Okay, so we have to find out the moment of inertia about OR. So OR is an axis, say, whose direction cosines are L, M, N. That is L, this equals to cos alpha, M, this equals to cos beta, and N, this equals to cos gamma. Fine. So we have to draw a perpendicular from the particle to this axis. Okay, say this is S. Okay, so if we are going to find out the moment of inertia along OR, so we must have to draw a perpendicular PS on OR. So what would be the moment of inertia of the entire body? Sum over of m dash into this perpendicular distance, that means PS square. Okay, so what is PS? Simply OP square minus OA square. And if this is R vector, so we can easily write m dash R square means x square plus y square plus z square. And what is OS? That is projection of OP on OR. Okay, OS is the projection of OP on OR. That means we can write Lx plus my plus nz whole square. Okay, because OS is nothing but the projection of OP on OR. So if we simplify it, okay, so we take x square common, that means 1 minus L square, plus y square common, this is 1 minus m square, plus z square common, that is 1 minus n square, minus 2lmxy minus 2mnyz minus 2nlzx. Okay, so let us do it further. Okay, so summation of m dash, this is 1 minus L square. We know that if L, M, N are the direction cosines, then L square plus M square plus N square, or cos square alpha plus cos square beta plus cos square gamma equals to 1. So instead of 1 minus L square, we put M square plus N square into x square plus y square into, instead of 1 minus m square, we put L square plus n square, and instead of 1 minus n square, we put L square plus m square, minus 2lmxy minus 2mnyz minus 2nlzx. Fine. Now we have to do a little simplification, that is m dash. If we take x square common, say not x square, that is x square. If we take common, then this is if we take L square common, this is y square plus z square, and if we take m square common, this is simply x square plus z square, and if we take n square common, this is simply x square plus y square. Okay, minus 2 lmxy minus 2 mnyz minus 2 nlzx. Okay, now what is summation over m dash into y square plus z square? That means distance of the entire body from x axis. So summation over m dash into this can be written as moment of inertia along x axis, that is ixx. Similarly, summation over m dash x square plus z square can be written as iyy, and summation over m dash x square plus y square can be written as izz minus 2 lmxy minus 2 mnyz minus 2 nlzx. Now in the picture we are going to find out the moment of inertia about the axis OR, and we take a point P there. This is S. So now along the axis OR, okay, along the axis OR, so let us take a point P dash in such a way that I is proportional to 1 by OP dash square, such that this relation holds good. Okay, so remember this thing, along this axis, that is OR, along which the moment of inertia is to be determined, we take a point P dash A such that I is proportional to 1 by OP dash square. So this is what, this is say m, say c to the power 4 by OP dash square. Okay, so why we take mc to the power 4? In order to make both sides dimensionally same, we choose this constant. Okay, we choose this constant in such a way as to make both sides dimensionally same, or no other reason. Okay, so if we substitute the value of I, then what would be the result? If we substitute the value of I, then L square Ixx OP dash square M square Iyy OP dash square N square Izz OP dash square minus 2 lmxy OP dash square minus 2 mn yz minus 2 nl zx, there will be OP dash square term. This is equal to mc to the power 4. M is the mass of the entire rigid body, and the one and only reason to take this constant is to make both sides dimensionally same. So this term L square OP dash square, that is L into OP dash, this is x. Okay, so x square Ixx plus y square Izz plus I square Iyy plus z square Izz minus, this can be written as mn OP dash square, that is the lm into OP dash square, this is Ixy, 2 Iyz yz minus 2 Izx into zx, this equals to constant. Here we choose lm into OP dash square, this as the product of inertia term. Okay. Similarly, mn op dash square, this has iyz, and nl op dash square, this is equals to izx. These are products of inertia. So what we conclude, this is an equation of an ellipsoid. Okay, that is the locus of the point p dash is an ellipsoid. We can clearly find, because I have to draw the picture again so that it is clear to all of you. Here we choose the axis OR and we take a point at P. This is say S. Okay, and along the line OR we choose any point P dash. Okay, along the line OR. So P dash is along OR. Okay, so obviously we find that locus of P dash is an ellipsoid. So the entire rigid body we took here. Okay, and obviously the point P dash represents the locus of the point P dash is an ellipsoid. Okay, so clearly it represents a quadratic surface. So this is known as momental ellipsoid. This is known as momental ellipsoid in 3D. Okay, 3D. And Ixx is moment of inertia along x-axis, Iyy along y-axis, and Izz is the moment of inertia along z-axis. And these are the product terms, Ixy, Iyz, Izx. These are the product terms. Okay. So clearly the rigid body describes a ellipsoid in this case. Okay. Now one thing I have to represent, that whenever we choose the axis in such a way that the product term vanishes. Okay, that is, one thing must have to know that these pairs, these product terms exists in pair and they are symmetric. That is Ixy equal to Iyx, Iyz equal to Izy, and Izx equal to Ixz. Okay, the pairs are symmetric. That's why we can write this. So if we choose the axis in such a way that this product term vanishes, then the corresponding axes are known as the principal axis. Okay, the corresponding axes are known as the principal axis, and under this situation Ixx, Iyy, and Izz are known as the principal moments of inertia. Principal moments of inertia. Okay, so under what condition we conclude this? If we choose the axis in such a way that this product terms vanishes, then the axes are known as principal axis, and the corresponding moment of inertia along three axes are known as principal moments of inertia. Okay, so as I told earlier that moment of inertia is a tensor. Okay, so moment of inertia is a tensor, so that can be written in this way: Ixx, Ixy, Ixz, Iyx, Iyz, Izx, Izy, Izz. This matrix form I can be written. Now for principal axis, what I would become, the product terms all vanishes. That means the expressions become this: 0 Iyy 0 0 0 Izz. So under these circumstances this relation holds good. Okay, so in this lecture we shall discuss the concept of momental ellipsoid in a simple way. Okay, and in my next lecture I shall going to discuss it more general way. Okay, and I shall discuss about few other things that you have to know. Okay, so here just I wanted to show you how the rigid body rotates about an axis, that forms the ellipsoid. Okay, and I is a tensor quantity, and I also tell about the principal axis and principal moments of inertia. So if you don't subscribe my channel, then kindly subscribe it to get latest videos on physics. Okay, so thank you.